All right, so we are reviewing our Unit 1 test review, and we're going to start off with number 1. Make sure you read all the directions in this test review just like you should for your unit test. And it says, directions, rewrite each of the radicals in simplest form. And then make sure to state each answer with the appropriate radical if necessary. So if it's square root, your answer needs to have a square root. If it's a cube root, your answer needs to have a cube root. Otherwise, it's considered wrong. Let's start off with the square root of 40. So we need to simplify by factoring out prime factors. We can have 2 and 20. That's another 2 and 10. That's a 2 and 5. And finally, 5 divided by 5 is 1. It's a square root, so we're looking for groups of 2. There's one group of 2's, so that comes down to the outside. And then 2 and 5 are just left over, so they'll be left over inside. 2 times 5. Or best answer would be 2 root 10. Final answer is 2 root 10. For the next one, we're taking the square root of 125. This definitely looks like it's divisible by 5. 125 divided by 5 is 25. That's also divisible by 5. Divide that by 5, 5, 1. It's a square root, so I'm looking for groups of 2. I've got 2 5s there. And then all we have left on the inside is a 5. 5 square root 5. Lastly, we have a cube root. So I've got 54, and that's divisible by 2. It's 27. That's divisible by 3, and you get 9. Divide by 3, you get 3. Divide by 3, you get 1. This is a cube root, so our answer is going to be a cube root, and we're looking for groups of 3's. I've got 3 3's right there. That goes on the outside. 2 is left over. 2 goes on the inside. 3 cube root of 2. With your calculator, you should always check your answers. So let's say I wanted to check number 3. Well, let's put the cube root of 54 in the calculator. Remember, a cube root, you have to go to math, and then it's that number 4 right there. So cube root of 54, enter. It's going to give us a decimal. Let's leave this decimal in our calculator, and now let's check our answer. We said that our answer was 3 cube root, so math, and then we got to go to 4, cube root of 2. So that was our answer. And let's see if they match. They do match. Now, the calculator can't tell us if our answer is simplified all the way, but it at least will tell us if it matches what we started with. We can do that same thing to check our answers for number 1 and 2 if you want to. If I can move this. So the first one was the square root of 40. The square root is just second x squared. Uh-oh, I hit something weird there. Anytime you hit something weird, just do second quit. So we do second square root of 40. That gives us that decimal. Our answer, remember, was 6 root 10, 2 root 10. So 2 square root of 10, and we get the same thing. Excellent. So that's one way you can check your answers. All right, moving on. Let's clear that. Whoopsies. So now we are looking at expressions that are in simplest radical form. Circle each expression that's in simplest radical form. Now, simplest radical form does not mean that the number underneath the radical, the radicand, it doesn't mean that it can't be factored. It just means that it cannot be factored so that either a group of 2 numbers or a group of 3 numbers come out. So this is what I mean. If I have 2 cube root of 10, 10, yes, can be factored. It can be factored 5, 2, 2, 1. So yes, it can be factored, but can we identify a group of 3 of the same factors? Well, 5 and 2 are totally different, so we can't take any groups out. So that means that this is actually in simplest radical form. So we would circle that. Yes, that is in simplest radical form. How about 3 root 11? Well, 11 is a prime number, so you definitely cannot factor that, so that is in simplified radical form. How about the square root of 14? Well, let's see if we can simplify this. So 14 is divisible by 2. That gives us 7. 7 is prime, so we divide it by itself. We're left with 1. So even though 14 itself can be factored, it's not able to be factored so that there are two of the same factor within it. So square root of 14 is actually in simplest radical form. Lastly, we're looking at the cube root of 27. So 27, 3 and 9, 3 and 3, 3 and 1. A cube root is a group of three of the same number. Yes, we can absolutely do that. Take that outside. When you have the cube root, there's nothing left inside here. So really, we're just going to get rid of that. Our answer is just 3. And anytime you have a cube root, check it in your calculator to see if it simplifies to a whole number like this one did. If you don't have your whole roots, your perfect cubes memorized yet, check it in your calculator. So let's check to see what we get when we do math and the cube root, so 4 of 27. And we get 3. A lot of times on our radicals test, people were writing that the answer was the cube root of 3 or 3 cube root 3. It's none of these, okay? The simplified form is just 3. And if you put it in that calculator, it's going to tell you it's just 3. All right, let's move on to the next one. So this next one says, determine if this is simplified correctly. So they want us to justify our answer. It just means to say whether it's true or not and show proof of it. So we're just going to do that by starting with the square root of 50 and doing what we would normally do to simplify it. We're going to break it down into 5 and 10, then 5 and 2, 2 and 1. It's a square root, so we're looking for a group of two of the same number. That's 5. 2 is left on the inside. So 5 root 2 is what we get. They're saying that the answer should be 2 root 25. Now you can definitely check your work. I would also pull up my calculator and check to see if what I got matches what we started with. So we started with the square root of 50. I'm going to clear this. And let's do second square root of 50. And we get that 7.07. Let's see what we get when we do 5 square root of 2. Awesome, we get the same number. Let's see what we get when we do their answer, 2 square root of 25. Oops, hit that wrong button again, sorry about that. So we have 2 square root of 25. And that gives us 10. So their answer definitely does not match. So does this radical simplify correctly? We would say no. The best answer is what we found. Best answer is 5 root 2. I think that's enough to justify that. Moving on, let's translate these into expressions. All right, so the first two are pretty similar to what we've seen. Which expression simplifies which expression represents 6 more than, so that's adding 6, 5 times a number, 5 times a number. So we would say, remember if you see 6 more than or 6 less than, it means it goes at the end. 6 more than 5 times a number. Now, this is the best way to write this answer. If they gave you a choice between 5n plus 6 or 6 plus 5n, this is the best option, because when you see the vocabulary more than, like 6 more than, that means that it's adding 6 at the end of the expression. So if you were given this choice versus this choice, this one right here is the best answer. I know I counted it both of these would be correct on our concept test, but on the unit test, I'm telling you, they're going with this one. Which expression represents 8 times the difference, so 8 times the difference of a 7 and a number. It's probably just supposed to say of 7 and a number. So let's just check this. Represents 8 times the difference, so 8 times, so that's where we're going to have the quantity, the difference of 7 and a number. And we would leave it just like that. You could always use x instead of n or any variable. Now getting on to number 8. So this is a more practical problem, but we're still going to apply the same thing that we're thinking about. Rosa earns $8.50 an hour at the shop for her normal hours, and she earns $12.25 an hour for overtime. Write an expression that represents her wages if N represents her normal hours and T represents her overtime work. So we're looking at N for normal hours and T for overtime work. Well, let's look at what they say about N. She gets $8.50 an hour for her normal hours. That means that she gets $8.50 for every normal hour she works. Then they have her overtime work. She gets paid $12.25 an hour for every overtime hour, or T. Her wages are going to be a combination of those two, a total of them, so we would add them together, and that would represent her wages. So our final answer would just be that. They might also simplify it. Instead of 8.50, they might just write 8.5. Both of them are correct. Lastly, on this one, we see write an algebraic expression that can be used to represent the verbal model 10 less than Tom's math grade. So let's just say his math grade, I mean, you can pick whatever variable you want. Let's say I say it's M. 10 less than, that means we're subtracting 10 at the end, Tom's math grade. So we just say M minus 10 or X minus 10, N minus 10, whatever. Okay, so those are the first 9 questions. I'll post more videos for the next ones.